Hi everyone, my name is Dawn, and today I'm going to go over this paper called Fast Model Editing at Scale, which was published in June 2022. So in this paper, they propose this technique called MEND, which stands for Model Editor Networks with Gradient Decomposition. And essentially what they propose is using a collection of small auxiliary networks to basically predict the edits to a pre-trained model's weights in order to make the factual edits that we want to make. So their approach trains these lightweight model editor networks, which we'll go over in a little bit, to produce the edits using the standard fine-tuning gradient of a given correction, which is the edit that we actually want to make. And it leverages the gradient as the information-rich starting point for editing. So at a high level, this is how the system works. So you start with a pre-trained LLM, and you have an edit that you want to make. For example, who is the Prime Minister of the UK? And then we have these gradients, the gradients with respect to the weight matrix for each layer of the model. And what MEN does is train a collection of MLPs to actually produce the delta tilde gradients for each layer of the model. And so that is the updated, that gets added to the original weight matrix to produce the updated weight matrix for each layer. And then that produces your edited model. And we want to see at the end is that the output of the edited model is aligned with the actual edit that we want to make. So how is this done? So what is the gradient decomposition part of this model? Essentially, one of the observations that the researchers make is that even though like gradients are high dimensional objects, so it's very costly to work with, but they can be decomposed into its rank 1 outer product form, which then becomes much more computationally efficient to work with. So specifically, if we dive deeper into how the MEND architecture works, we see that they have they start with the gradient for the weight matrix at some layer L, and they decompose this into this top part, which is the inputs to layer L. And then the bottom part, which is the gradient of the loss with respect to the pre-activation inputs to layer L plus 1. So these two are concatenated together and fed into the MLP. And then the output of this is then multiplied together to get the update, the rank. So we have like the rank 1 update, and then it's multiplied together. And this essentially, the output is then added to the original weights to produce the edited weights. So on this next slide, basically we see here the final edited weights are the original weights minus some alpha, which is a learn per layer scalar, times the output of the MLP for each layer. And so how is the MEN network trained? So the authors define this loss function, which consists of 2 components. So the first component controls for edit success. So we're trying to essentially maximize the probability of the new target given the prompt that we want to edit. And then the second part of the loss is this KL divergence term, which essentially just tries to preserve the model's behavior on unrelated inputs. So like prompts that are unrelated to the specific fact that we want to edit. So the total loss is the combination of these two loss functions. And here are some examples of kind of the pre and post edit outputs. For example, here, who is the Prime Minister of the UK, and the pre-edit output of the model is Theresa May. And then we want to edit the output to Boris Johnson, and we see that after we apply the MEND algorithm, the output has been successfully changed to Boris Johnson. So in terms of like broader evaluation metrics, the authors show that MEND significantly beats these other methods, such as like fine-tuning on specific metrics that we care about, such as ES, which is the edit success rate. So MEND has a 0.81 score on edit success for the wiki text generation data set and a 0.88 score on the ZSRE QA data set. So I think at the point in which this paper was released, this was definitely like state-of-the-art algorithm for model editing. Some limitations that I've noticed for the MEN algorithm is that one, it still requires, a good amount of work to train MLPs for each layer of the LLM that you're trying to edit. So it's still a rather, complex solution. Second one is that it doesn't attempt to narrow down changes to the model to specific layers, unlike other techniques such as Rome or Mehmet that use causal tracing to try and identify which layers of the model the knowledge is stored in. So this MEND approach essentially tries to update all of the layers. And then the third limitation is that we are editing this, black box LLM with more black box models. So there definitely is kind of interpretability issues here. It's definitely a harder to interpret technique compared to, for example, again, like Rome or Mehmet, which have more analytical solutions that are more intuitive. So that is it about MEND, and I hope this video was helpful.